this episode, we're going to build a skill that sits underneath almost every good detection program, even though it rarely sounds exciting at first. Creating baselines for what normal looks like across networks, data, and user behavior so alerts feel credible instead of random. When beginners picture security monitoring, they often imagine the system magically knowing what is bad, but in real life the system has to compare what it sees right now against what usually happens. If you do not know what usually happens, you cannot confidently say something is unusual, and you end up with either constant noise or dangerous silence. A baseline is the structured understanding of normal patterns, captured in a way that helps you spot meaningful changes, not just minor variation. This is how a Security Operations Center, SOC, avoids chasing every odd detail while still catching the events that truly matter. By the end, you should understand what baselining means, why it makes detection trustworthy, and how to think about baseline quality without getting stuck in tool-specific details. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A baseline is not a single number or a rigid rule, and that is an important misconception to clear up early. For many beginners, the word baseline sounds like one straight line you can draw, and everything above it is bad, but real environments are full of cycles and variation. People log in more on weekdays than weekends, systems behave differently during maintenance windows, and business workflows create spikes in network and data activity that are perfectly legitimate. A baseline is therefore a range of expected behavior shaped by time, role, system function, and business rhythm, and it must account for seasonal and operational patterns. It is also not meant to freeze the organization into one mode of operation, because change is normal and baselines must evolve. The purpose is to create enough understanding that when behavior shifts, you can ask a good question: is this expected change, or is this a sign of misuse or failure? When baselines are treated as living understanding rather than fixed rules, detection becomes more accurate and less exhausting. Baselines matter because detection is fundamentally a comparison problem, and comparisons only work when the reference point is trustworthy. Without baselines, an alert often becomes a guess driven by generic thresholds, and generic thresholds rarely fit a specific organization's reality. This is how teams end up with alert fatigue, where analysts see so many false alarms that they stop trusting the system, and the one real signal is missed because it looks like more noise. Baselines reduce false positives by explaining normal patterns, but they also reduce false negatives by highlighting subtle deviations that would otherwise be invisible. They make it easier to prioritize because an unusual event in a critical system or a privileged account carries different meaning than an unusual event in a low-impact area. Baselines also support communication, because when you tell a system owner that an action is unusual, you can explain unusual relative to what, rather than just claiming it feels suspicious. Credibility in detection is not about sounding certain. It is about being able to justify why something stands out. Network baselining is a good place to start because network behavior is often the earliest place where changes show up. At a high level, network baselining is the practice of understanding typical communication patterns, such as which systems talk to which other systems, at what times, and with what general volume and direction. Beginners sometimes assume network monitoring is mainly about blocking bad destinations, but baselining is more about relationships and patterns. If a server that normally talks only to a database suddenly starts communicating broadly to many systems, that shift may matter even if every destination is technically allowed. If a workstation that normally communicates mostly within internal services begins sending large volumes of traffic outward at unusual hours, that pattern deserves attention even before you identify an obvious malicious signature. Network baselines also include what normal looks like for remote access, partner connections, and administrative activity, because those are common paths for misuse. When network baselines are well understood, unusual communication becomes a clue with context rather than a random anomaly. A practical way to think about network baselines is to focus on expected paths and expected boundaries. Expected paths are the usual communication flows that support business processes, like user traffic to business applications and application traffic to data services. Expected boundaries are the limits that should rarely be crossed, like low-trust zones suddenly reaching high-trust zones, or user devices suddenly acting like servers. Even without technical configuration details, a beginner can understand that systems have roles, and roles imply normal patterns of communication. A file server does not normally initiate large numbers of outbound connections like a web browser, and a user device does not normally receive the same kinds of inbound connections as a service. Baselining helps you translate those role expectations into observable patterns, which in turn helps you ask better triage questions when something shifts. It also helps you avoid overreacting to normal bursts, because you can recognize known business cycles and plan changes. The baseline becomes your operating memory for what the network looks like when it is healthy. Data baselining is just as important, and in many ways it is closer to the organization's true value because data is often what attackers want and what organizations must protect most carefully. Data baselining means understanding how data is normally accessed, moved, changed, and stored, including who typically touches it and through which processes. Beginners often think of data risk only in terms of theft, but integrity and availability matter too, because data that is silently altered can be just as damaging as data that is exposed. A baseline might include normal access volumes to sensitive repositories, normal download or export patterns, and normal change patterns such as batch updates at specific times. It might also include normal sharing behaviors, like which teams exchange data and how often. When these patterns are known, unusual activity becomes visible, such as a sudden export of an unusually large dataset or access to a sensitive dataset by a role that does not typically use it. Data baselining also supports accountability because it helps identify which owners should be involved when data behavior changes. One of the most common beginner misunderstandings is to treat data baselining as purely a storage problem, as if it only applies to databases or file systems. In reality, data behavior also includes how applications read and write data, how reports and analytics pull data, and how integrations move data between services and vendors. Many risky moments occur at the edges, such as exports, automated transfers, and account-to-account sharing that bypasses normal application controls. A baseline that ignores these edges can look stable while the organization quietly leaks or mishandles data through normal-looking pathways. Data baselining, therefore, depends on understanding data classifications and business workflows, because what counts as unusual depends on what the data is and what it is used for. A developer accessing test data may be normal, but a payroll clerk accessing development repositories may be unusual, and the baseline helps you notice role mismatches. When you see data baselining as behavior across the full lifecycle, not just storage, you gain a clearer picture of where data risk actually lives. User behavior baselining is the third pillar, and it is often the most delicate because it touches human patterns and can easily become noisy if handled clumsily. At a high level, user behavior baselining means understanding how accounts normally act, including login patterns, access patterns, and administrative actions, in ways that support security without assuming that every deviation is malicious. Beginners sometimes assume an unusual login time automatically means compromise, but many legitimate reasons exist, such as travel, project deadlines, or on-call responsibilities. A strong baseline accounts for roles, because different roles have different normal patterns, and it accounts for seasonality and business cycles. It also recognizes that people change jobs, teams, and responsibilities, which can make yesterday's baseline less accurate. The purpose is not to police normal life, but to detect meaningful shifts that could indicate stolen credentials, misuse of privileges, or insider-driven activity. When user baselines are thoughtful, they support both security and fairness by focusing attention on patterns that are truly out of place. A powerful beginner concept is to think in terms of identity context, because identity context turns raw events into something interpretable. Identity context includes whether the account is privileged, whether it is used by a human or by an automated process, what role it is supposed to perform, and what resources it normally touches. Without this context, an alert about access can be meaningless because you do not know whether the action is unusual for that identity. With context, you can distinguish between a routine administrative task and a suspicious privilege use, even if both involve similar systems. This is also where ownership matters, because identity owners and system owners can confirm whether a pattern is expected based on business knowledge. Baselining, therefore, is not only a technical task, it is also a knowledge task that ties systems and people together. Beginners should remember that most detection failures happen when events are interpreted without context, leading to either panic over normal behavior or complacency about truly abnormal behavior. Identity context makes detection a reasoned practice rather than a reaction. Baselines also have to deal with the idea of normal change, because organizations evolve, and baselines that cannot absorb change will break quickly. A baseline should be built with an understanding of what drives variation, such as business hours, release cycles, maintenance windows, and seasonal demand. It should also include a way to incorporate planned changes, like migrations or new services, so that expected shifts do not flood analysts with false positives. At the same time, baselines should not blindly accept all change, because attackers and failures can hide inside change, especially during chaotic periods. This is why it helps to treat baselining as a continuous learning process, where you regularly review patterns, update expectations, and keep a record of what changed and why. A baseline is credible when it is backed by observed history and deliberate updates, not when it is set once and forgotten. Beginners should see that baselines are most valuable when they help you tell the difference between a known change and an unknown change, because unknown change is where risk often enters. A practical way baselining improves detection credibility is by supporting better triage questions and faster narrowing of scope. When an alert triggers, a baseline helps you ask whether the behavior is unusual for that system, unusual for that identity, unusual for that time, or unusual for that data type. If the answer is no in all categories, the event is more likely to be noise, and you can close it faster with confidence. If the answer is yes in multiple categories, the event is more likely to be meaningful, and you can escalate faster without feeling like you're guessing. Baselines also help in determining blast radius, because if you know what normal communication and access patterns look like, you can identify which adjacent systems or accounts might be affected by the same event path. This improves response because you move from examining a single alert to understanding a possible scenario. For beginners, it helps to see triage as pattern matching against normal, not just as checking whether a rule fired. Credible detection is less about perfect certainty and more about consistent, explainable reasoning. Baselines become even more powerful when they are connected to control objectives, because then you can monitor whether controls are working as intended. If a control objective is to limit access to sensitive data to certain roles, the baseline should reflect that expected access pattern, and deviations should stand out clearly. If a control objective is to limit lateral movement inside the network, a baseline of normal east-west communication can reveal when a system starts probing or connecting in unusual ways. If a control objective is to ensure stable service operation, a baseline of normal service interactions and traffic volume can reveal early signs of disruption, misconfiguration, or emerging failure. This connection prevents baselining from becoming a separate hobby and makes it part of risk management and control effectiveness monitoring. It also helps prioritize what to baseline, because you focus first on the areas where tolerance is low and impact is high. Beginners should understand that baselines are not valuable because they are clever. They are valuable because they help confirm whether the organization's protections match the reality of operations. When baselines reflect objectives, the SOC can report drift with credibility and urgency. Threat intelligence also becomes more usable when baselines exist, because intelligence often tells you what kinds of behaviors to expect during certain attacks. If intelligence suggests attackers are using credential misuse followed by unusual data access, baselines help you identify what unusual looks like for credentials and data in your environment. If intelligence suggests attackers are targeting a specific type of service and moving laterally, network baselines help you notice unexpected new communication patterns between systems. Without baselines, threat intelligence can feel like a list of scary possibilities with no clear way to connect them to your actual environment. With baselines, intelligence becomes a guide for what anomalies matter most and where you should tighten detection. This is also where prioritization improves, because you can focus on the anomalies that represent meaningful deviation rather than chasing every match to a generic pattern. For beginners, the big lesson is that threat intelligence and baselining strengthen each other, because intelligence suggests what to watch for and baselines show what is unusual enough to deserve action. Together, they make detection more precise and less noisy. Baselining can go wrong, and understanding the failure modes helps beginners avoid a lot of frustration later. One failure mode is baselining the wrong thing, such as collecting huge volumes of data without linking it to decisions, which creates storage and noise without improving detection. Another failure mode is baselining too narrowly, so normal variation looks like an anomaly, flooding analysts with false alerts and eroding trust. A third failure mode is baselining too broadly, so the baseline includes abnormal behavior, especially if attackers already have a foothold during the baseline collection period. A fourth failure mode is failing to update baselines when the organization changes, making the baseline stale and misleading. The cure is not to abandon baselining, but to treat it as evidence-based learning with clear objectives, careful review, and ongoing adjustment. Beginners should also remember that baselining is not meant to replace other detection approaches, because known bad signals and rule-based detections still matter. Baselining is the credibility layer that helps you interpret signals, not a single magic detector. To conclude, baselining network, data, and user behavior is how a detection program becomes believable, because it gives the SOC a trustworthy reference point for what normal looks like, and therefore what truly stands out. Network baselines capture normal communication relationships and boundary expectations, so unusual paths and unusual volumes become meaningful clues rather than random surprises. Data baselines capture how sensitive information is normally accessed, moved, and changed, so unusual exports, unusual role access, and unusual modification patterns can be noticed early. User behavior baselines capture role-based identity patterns, so credential misuse and privilege anomalies can be detected without treating every human variation as suspicious. When baselines are treated as living knowledge that adapts to change, they reduce alert fatigue, improve triage speed, and support defensible reporting about control effectiveness and coverage. They also make threat intelligence more actionable by providing a clear way to recognize the behaviors intelligence warns about in your specific environment. If you can explain what normal looks like, how you know it is normal, and why a deviation matters to outcomes the organization cares about, you have made detection credible, which is the foundation of effective security operations.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.